Hey everybody, I wanted to take a moment here and create a video that walks through the basic fundamentals of what is NPS and how to troubleshoot some of your more common scenarios. So this video is sort of aimed more for those people who really don't have much exposure at all to NPS and are looking to try and figure out what exactly the logs are telling you and how we can break down and simplify the troubleshooting process. So first of all, NPS is a very old technology. There's a protocol called Radius, which was created way back in the dial-up days. And so Radius is a very quick authentication protocol. And so when this was designed, authentication would happen extremely quickly. You'll notice if you ever go to set NPS up, the default timeouts are around 3 seconds. So if things didn't happen within 3 seconds when this was set up, then the authentication timers would time out. However, what we have done is we've created this extension that sort of gets wedged in the middle of the authentication flow within NPS called MFA, multi-factor authentication. So that process takes much longer than 3 seconds. And this is one of the issues that you'll encounter when you troubleshoot NPS, is these default timers that exist on all the devices that are out there trying to utilize Radius. So let's look at the NPS console and talk about what's there. So in NPS, you've got a few things, and depending on what version of server you install it on, this may look slightly different. Like in 2012, there's some additional features. These are not features that have any bearing on the troubleshooting that we're doing here. This is aimed specifically at troubleshooting NPS as it relates to the NPS extension doing multi-factor authentication. So in NPS, you've got this area called Radius clients. Radius clients are the devices that are sending requests to NPS. They're using Radius as the protocol, so we call them Radius clients. And you need to have entries set up for each of them. As you can see here, I don't have just individual IP set up. I've used entire subnets. But you can set them up individually. And with each entry, you've got what's called a friendly name. This will be important because depending on how you set up your policies later, you may or may not use this name. This is also referred to as client friendly name because these are Radius clients. So this is the client friendly name. And with each of these, you have a shared secret. Now, a lot of people believe that the use of some authentication methods are not secure, like PAP is an authentication method, but the shared secret is the encryption key for those clients. So while it can be left blank, as long as you have a shared secret here, nothing is ever sent in the clear. So these are the clients that are sending requests to NPS. NPS can also send its requests somewhere else, and it does that through the use of remote Radius server groups. So in here, in each group, you can have one or more Radius servers that we send requests to. And each of these has their own settings. IP address, you'll see here again a shared secret. And on the load balancing tab, these are the timers that says how long are we willing to wait before we consider a request bad. 30 seconds is what I have here, but in most cases with MFA involved, these should be more like 30 and 60. So we'll wait 60 seconds before we consider a radius request dead. But for my lab, I've shortened it. All right, now let's go down and let's talk about the policies. So in NPS, we've got two kinds of policies, a connection request policy and network policies. The easiest way to understand how these are different is to think of connection request policies as what NPS uses to decide where authentication will happen. Will it happen locally, or will it happen on a remote radius server? And so in that, we can see these two options. If you highlight a policy, you can see the summary of the settings of the policy here. So here are the conditions. The condition is 24/7 for me. I've just used a day and time condition to keep it simple. And what the conditions say is if it matches this condition, then I want to apply these policy settings to it. Conditions aren't ever used to say, yes, you're allowed or you're not allowed. All the conditions are for is to say which policy gets applied. And within that, we determine where authentication will happen. In this particular policy, I'm saying I want it to be handled locally. What that means is that this connection request policy, if matched, will then send it to the network policies where authentication actually happens. I have another policy here which says, hey, if the request comes in and this is the username in the request, I want you to send it to a different radius server, which is the group that I've defined up here. Okay, so now let's talk about network policies. Network policies are where authentication happens. In this policy, you'll see again, I have a day and time restriction to keep it simple. I only have one policy, so I only need a very simple condition. If I had multiple policies here, I may be using different things. In some cases, like with setting up a remote desktop gateway, in that instance where we're only sending a username and not the password, this condition would be different. I would have a radius client entry for my remote desktop gateway, and the condition that I would use would be the client friendly name that we talked about before. This is the name that you have given your radius client. It's not the name of the device, it's the name that you defined when you created the radius client entry. So again, conditions are just used to see which policy we want to match on. And then once that policy has been matched, then we start to look at other things like the authentication methods. Again here, these are the list of authentication methods that this policy will accept. This is not saying they must have all of these. This is saying they can have any of these selected. There's a couple that you can add up here, add to the list, but these are all the ones that we will accept. Normally the rest of these things are left default, not set, but they may have other things set back here. They may have attributes set, they may have other things, but the heavy lifting is done here with your restriction or your condition and the constraints. All right, so that's the basic fundamentals there. Radius clients are what send you requests. Remote radius servers are where if we need to send a request somewhere else, we will send it to this group. Connection request policies determine where authentication happens, and network policies are what performs the authentication. Now, I've got a couple of other tools open here. One of them is called NT-RADPing, and this is a basic radius testing tool. This is what can create a radius request, and I'll be able to send that request to my NPS server. I've also got my Android running through Android Studio, so I can run my Authenticator app. In addition to that, I've got Wireshark running in the background, and I'm going to go ahead and start that. Confirm that I can see packets coming in, and once I do, I'm just going to type in radius, hit enter, and so now I'm only looking at what radius traffic is showing up. You'll see I'm still capturing packets down here, but I'm not showing anything because I haven't received any radius traffic yet. So let's go ahead and attempt a radius request and see if we can get all the way through. So in this case, I've already got the client entry set up. This is the shared secret between the two, this user and the password. Let's go ahead and send it. So if you'll notice, I got an immediate rejection. There was no MFA that was tried. Nothing happened. So why is that? I can see here in my trace, the request came in. If I look down inside the traffic, I can see a user was sent and a password was sent. So what is the problem? Well, we need to dig into the event logs. And there's two places that you need to look. The first is in the customized view. This is a filtered view of what's down in the security logs. This is all NPS related events. So 9:56, you'll see that was the timestamp of when I tried, and all the good stuff that you need to see is going to be down in here. Okay, so we see we matched the username CRP, but we don't have anything else here. So why did it fail? Okay, an NPS extension DLL that is installed on the NPS server rejected the connection request. Well, that's not extremely helpful, is it? It doesn't really tell us anything. And the reason for that is because on this server, on this NPS server, I've got the MFA extension installed. When the MFA extension is installed, the NPS logging is changed because the MFA DLL is in the authentication flow. So to get a better idea of what happened here, I need to go see what this DLL, this MFA DLL, has actually recorded. So when you go down into app logs and app and service logs, Microsoft Azure MFA, there's two categories here. Normally, the stuff that matters is going to be down in these two logs, and predominantly it's going to be down in this bottom one. So here's my event. I've actually got two here, so let's see what the first one says. So this error that you see is not really an error. You can ignore this. This is essentially, there is a registry code that you can set. And after you've started NPS for the first time, it loads the DLL. The DLL will check the registry. And when it does, it looks for this registry key. If it's not there, it will record this. By default, it's not there. So in most cases, you'll see this every time. So let's look at our next one. So here's the actual error. Okay, and what this is saying, you need to understand that there's two, basically when you install the MFA DLL, there's two kinds of logging. There's the NPS logging that we discussed, and that is all primary authentication. No matter what the result of primary authentication is, the network policy that does the authentication will hand that off to the MFA DLL. So whether it passes or fails, it doesn't matter. It's going to hand it off to the MFA DLL. And when that happens, the MFA DLL has to decide if it's going to even attempt MFA or not. In this case, what we see is the MFA is saying, It's here to perform secondary authentication for requests that are in an access accept state. That means it's passed. However, this request received for this user came in an access reject state. What that is saying is that primary authentication has failed for this user. Now, it can fail for several things, but in my case, I don't have a Windows group condition, so it wouldn't fail for that. The only other thing it could be would be the password. Now, if the user is absolutely certain that they're typing in the correct password, then it could simply be that this shared secret between this Radius client entry and this Radius client don't match. Remember, this is your encryption key for the password. So what is happening is the Radius client is encrypting it with whatever you've set the shared secret to be. And then it sticks it on the wire. That comes in because we have an entry here for this Radius client. It accepts the Radius request. It decrypts it based off of its shared secret. And if that shared secret doesn't match, then the decrypted password isn't going to be what the user sent. However, that's not the case in this case. The case in this case is the password I sent is incorrect. So let's try this again. And this time, I'm going to send the right password. All right, so let me update the password and let's see if we can get this to work. Let me go ahead and clear this out, stop this again, continue without saving. All right, so we're looking at fresh stuff. All right, so let me send this guy. Okay, so now we got the MFA prompt. You see an access accept has come back. Now, if I were to refresh my logs here, now when I look at the user request, access has been accepted for this user, response, and success, et cetera, et cetera. Now, when you're troubleshooting these things, you'll notice you have a correlation ID. The only time you have this is when you actually send the request to Azure. So in Azure, you can open up the sign-in logs and then use this correlation ID to find additional information. Okay, so now that this is working, let's take a quick look at, let's say the user swears they're sending the right password, and they don't understand why it could be wrong. So what we're going to do is I'm going to put in the wrong password again so that we can get some failures. Now what we need to do is we need to be able to confirm primary authentication is working. So even though our errors might be telling us that it comes in a reject state, the problem is that our logging for NPS is truncated. We can't see everything that's going on because the DLLs are in the authentication logic flow. So the way that we can do that, the way that we can ensure primary authentication is working is we can take MFA out of the equation entirely right now. The way that we do that is we pull out the pointers from the registry that are telling NPS to load the DLL, and by doing that, we force it to only be able to perform primary authentication. So down in HG local machine, system, current control set, services, and then auth serve, AUTH-SRV. You'll expand that, and in parameters will be 2 entries here. These point to the 2 DLLs that the MFA extension uses, that NPS loads when it starts up. If this exists, then it will load these DLLs, and it will be attempting MFA with every request that goes through it. So the way to do this is, the best way is to just back up this key. So export. In this case, I've already got it exported here, and I exported to my desktop. So once it's exported, you can come in here and you can just delete these keys. And with them gone, the next thing that you want to do is go in here and restart the NPS service. So click stop. Normally stop takes 5 or 10 seconds to shut the service down. So when you right click on it again, sometimes stop will still be there. And then go ahead and start NPS. The best way to ensure that NPS is actually started is wait another 5 or 10 seconds. Right click on it again and make sure that stop is your option. Now you know that it's stopped properly and it has started properly. Now with that change in place, let's go ahead and attempt a radius request again and see what happens. Okay, so we got a reject right away again. So let's go take a look at our logs. Let's refresh our NPS log. There's our last entry, denied access. So let's go down here and see what's going on. All right, so this is pretty straightforward. Authentication failed due to a user credential mismatch. All right, well, that's pretty straightforward, and we knew that that was the problem anyway. But as you can see, once you have taken the MFA DLLs out of the logic flow, that cleans up your NPS logging. And so that makes it much easier to troubleshoot a problem, because you may see other issues like let me modify my constraints here. Let's uncheck this. Let's just do all that. So now in the constraints, I'm only saying I want to allow MS Chat v2 because I believe that that's the secure, and maybe that's a corporate mandate. Let me go ahead and apply that. I can see down here that the network policy has updated. Let's go back here. Let's take a trace again. Now what I am going to do is I'm going to fix this password. So I know my password is right. So let's try this again. I got an immediate reject again, so let's go and see what's going on here. Refresh the logs. Look at the entry. I'm going to go down here. Now it's different. The user attempted to use an authentication method that is not enabled on the matching network policy. Pretty easy to read, right? Here we can see the authentication type is PAP. That is what this client is using. It can only support PAP or CHAP. So PAP, if this is not checked, is what it's using. If we go back to our network policy, we've only got one. And even if we had multiple ones, you can see here, we see the name of the policy, the connection request policy that was matched, and the name of the network policy that was matched. So we need to look at this network policy since we matched it and see what are the authentication methods. The authentication methods are defined under constraints. It's using PAP, but PAP is not allowed. You go ahead and apply that. When you do that, you get this pop-up saying you've selected one or more insecure authentication methods. It can blah, blah, blah. So this is saying, hey, this can be insecure, and it's true. It can be insecure. It's as secure as your shared secret makes it. Remember, that's your encryption key. click no here, otherwise it will open up a help topic. We can see now that we do EAP or PAP. So let's try this again. Now that we've updated our network policy to support an authentication method that we have, what happens? Now it works. So you can see that troubleshooting NPS is not a terribly challenging thing if you understand the fundamentals. NPS does primary authentication, and then it leverages the Azure MFA component to perform MFA. Now that we have this working, now that we have primary authentication working, we need to put that registry key back. So the easiest way to do that is to go back, find that exported key. You can just double click on it. It will import it. You can confirm that it's there. If you go look here, you'll see those reg keys are back. All right. Let's stop this. Wait a few seconds. Right click again. Still says stop. All right. Start NPS again. Now when we restart it with those reg keys there, we should be doing MFA. Let's see if that's the case. There we go. We're performing MFA. So if you break this down into fundamental pieces, troubleshooting these NPS issues generally are not challenging. That goes for fairly straightforward NPS installations. Of course, NPS has been around for a very long time, so there may be instances, there will be instances where customer environments are not at all this basic. They'll be very challenging. But if you take it piecemeal, you can still troubleshoot these things pretty easily. So hopefully this video has helped kind of shed some light on what NPS does, how it does it, and what we can do as engineers to simplify the troubleshooting methodology. Thanks.